This section is on polynomial and rational inequalities, and our answers in this section are going to be in interval notation. So interval notation is a way to describe an inequality. So if x is between -5 and 8, including 8 but not including -5, and this is what it would look like on a number line, then your answer in interval notation would be parentheses -5, comma 8, and then a bracket. So in interval notation, you report the leftmost boundary and you report the rightmost boundary. And these are some other examples right here. So my directions say solve the inequality, show the number line, and express the answer in interval notation. So I'm looking for where is this less than 0, meaning where is this going to be negative. So I do this really by making a number line, and I want to have cutoff points on the number line. And the cutoff points, these are where it's going to be equal to 0 or undefined. So the cutoff points on my number line are where this equation is equal to 0 or undefined. So if I were to just set this equal to 0, it's already been factored, so each of the individual factors, I can just worry about those. So x minus 3, if you set that equal to 0 and move the 3 to the other side, you would get x equal to 3. X plus 5 would be x is equal to -5. And 2x plus 5 would be x is equal to a -5/2. So if we were just solving this equation, these would be our answers. But because this is an inequality, then these are just going to be our cutoff points. It's not going to be our final answer. So I need to make a number line, and these are my cutoff points. Okay, so I need to now make test points. And I actually want to use the table command on the calculator. So to use the table command, I took some pictures of my calculator. First we need to get our table into the right mode. So if you do second and then window, it'll take you to table settings. And you want to make sure that your independent variable is set to ask and that your dependent variable is set to auto. So once you do that, well, first of all, you want to make sure that you enter in your actual equation into the y equals. So if you enter that into y1, and then make sure the table setting is in that correct mode, but then go to table. So second table, again your function is already entered into the y equals at this point, or should be. Now you can really type in x values and it will give you the appropriate corresponding y values. So if I actually just type in the cutoff points themselves, so 3, -5, and -2.5, these should each register as 0 when you plug them in, because that's where it's equal to 0. So this is kind of a good check to make sure that you have the right cutoff points. Then I need to pick points really within the regions, and you'll see here I have -6, -4, 0, and 4. Let me talk about where I'm getting those. I basically need to pick points in between these numbers. So I picked -6 because it's right here, and then I picked -4, and I picked 0, and I picked 4 because they lie in between these points. So if you do that, we're actually just concerned with the sign. So you'll notice that I have a negative 63 here. I don't really care about the fact that it's a 63. I care about the fact that it's negative. So I'm only really concerned with signs here. So this is a negative region, meaning the function is negative within that interval. If I look at, if you plug in negative 4, you get 21, specifically a positive 21. So that would be a positive region. If you plug in 0, you get negative 75. I only care about the fact that that is negative. And then lastly, if you plug in 4, you get 117, which is positive. You don't need to pick the exact numbers that I picked, meaning if you wanted to pick 5 for this region, you would still get a positive number. If you wanted to pick 10 for that region, you would get a positive number. You just need to pick some number that's greater than 3 to figure out if this region is positive or negative. So now that we've identified the positive and negative regions, we need to decide which one we actually want. So if you look back at the original question, it says that it's less than 0, or we're looking for where it's less than 0. So less than 0 means negative. So we want the negative regions. So my answer would be this region and this region. So in interval notation, that is negative infinity all the way up to negative 5. And I'm not going to include negative 5 because it's strictly less than 0. And then union that with negative 5 halves to 3. And that would be our answer. So any number within these two regions will make the original inequality true. So it's not just one number, it's actually an interval of numbers that make the original true. So that's really why we use the number line here.